series webinar uh, delivered by Dr. Sreenath Dixit. It is my privilege to welcome Dr. Sreenath Dixit, Principal Scientist and Strategic Advisor to Director General of a very renowned organization, the ICRISAT, International Crop Research Institute for Semi-Arid Tropics, which is working with around 15 countries on various agriculture development issues. Today, incidentally, is also a World Soil Day. I'm very happy to have Dr. Sreenath Dixit. All through his profession, he worked on sustainable natural resource management. He worked for the soil, and it is our privilege to have Dr. Sreenath Dixit as the speaker. It is just a coincidence, but it is very interesting. I would like to take 2 minutes to briefly introduce today's honorable speaker, Dr. Sreenath Dixit. Dr. Sreenath Dixit is at present working with ICRISAT as principal scientist and strategic advisor to Director General. Basically, he holds a doctorate from University of Agriculture Sciences, Bangalore, in agricultural extension. He worked on impact of IRDP, Integrated Rural Development Program, on the people livelihood, income, welfare. Interestingly, that is a mandate of CIRDAP. It is another coincidence. In 1991, Dr. Sreenath Dixit joined a very prestigious Indian Agriculture Research Service. He worked as a scientist in National Research Center for Cashew. Later, he joined another institution of international importance, CRIDA, Center Research Institute for Dryland Agriculture. Basically, he focused on sustainable natural resource management and rural livelihoods. And one of the most important and notable contribution during this period is the preparation of, the district plans under NICRA, National Initiative for Climate Resilient Agriculture. These plans, district plans, are very useful for practitioners. Not only now they are confined to 100 districts, it is widely used, not only within the country, but even other countries also. And later he served as director Atari. It is a an institution, agriculture technology application research institute based at Bangalore, India. He looked after Krishi Vignan Kendras. They are farm science centers, very critical link between research system and the farmers, located at district level. He took care of all the farm science centers in southern India. Later, he joined, ICRISAT, and in ICRISAT, he made notable contribution on knowledge management, and he also served as the ICRISAT Development Center, which is a very important center through which he implemented around 24 projects worth of 30 million US dollars. So there is a long list. I don't want to elaborate, but he's a man of natural resource management, and he published more than 180 articles, and of course more than 100 popular articles in the newspapers and other magazines. It is our privilege, Dr. Sreenath Dixit, to have you speaker here, and welcome to 36th webinar. And he is going to deliver a talk on ICRISAT, 5 decades of excellence in alleviating poverty in South Asia, which is very close to the very mandate of CIRDAP. I'm very happy to have participants from other countries. I'm sure that they will enjoy this talk. Over to Dr. Dixit.
Thank you very much, Dr. Chandrasekhar. It's a privilege, and very thankful to you for a very generous introduction to me. Without taking much time, I will straight away share my presentation. And after the presentation, maybe we can have a chat over some questions and answers. So here is my presentation. Please confirm if it is seen on the screen.
Yeah, it's seeing, sir.
Thank you. Thank you very much.
Thank you.
Yes, it's a very, very strange coincidence that today also happens to be the World Soil Day. And all through my career, I mostly worked on natural resources important for sustainable agriculture, and soil being a very important resource, not only the soil and the rainwater and its management. So let me take you through one of the 15 gems of what we call a consultative group on international agricultural research. The International Crops Research Institute for the Semi-Arid Tropics has been in existence for over 5 decades. Existence way back in 2022. Now we are 52-year young institute. So this, this institute has been, it is taking a little while for changing the slides because it's a heavy file. Just give me a minute.
Full slide view.
Yeah,
Full
I think
slide view.
it's there now. You're able to see this? Yes.
Yeah, it is.
Yes, sir.
Yeah.
Yes, sir.
Okay, thank you. As I said, ICRISAT is a pioneering international scientific agriculture research institute, and it specializes on improving farming in drylands and the agri-food systems of the drylands. So as you all know, drylands constitute a very significant percent of our global agricultural land. Nearly 44% of the agriculture, global agriculture, is on drylands. And nearly 3 billion people, to be precise, 2.7 billion people, almost twice the size of India's population, depends on these drylands. And half of the world's livestock also are reared in these drylands. As you know, the drylands are characterized by risk-prone agriculture, livestock-based, and smallholder farming. So these are the layers of risks that farmers in these places always face. So now, as you see, ICRISAT being an international institute, it has presence across the globe, mainly in India. It is based as headquarters in India, and its major work happens in India because India's sizable agriculture depends on dryland agriculture. And if you can see this ICRISAT's global locations, we have quite a few offices, country offices in East and Southern Africa and West and Central Africa. So we work in one of the few of the most difficult areas in the world, particularly in the African continent. So to take you back to a little bit of history of ICRISAT, as I said, we are in the 52nd year of our existence. 1972, ICRISAT was born. And as you all know, the father of Green Revolution, the architect of India's Green Revolution, Professor M.S. Swaminathan, whom you can identify in the third from the left, sitting in whites. Dr. Swaminathan is one of the founding members of ICRISAT, and he always believed that systems can really strengthen the way ICRISAT can bring prosperity not only to India, but to the world as well. One of the first tasks ICRISAT took up after being established is to go out and scout for the existing variability in 5 crops. I'll just come to those these 5 mandate crops were, I'll just go to the few slides. I'm now into the presentation mode. Yeah, these 5 mandate crops were collected from across the world. I hope you're able to see this global distribution map in which ICRISAT Gene Bank collected more than 15,000 accessions of groundnut, which is a mandate crop, dryland crop, chickpea. We also call this as Bengal gram. More than 20,000 accessions of Bengal gram from about 61 countries. Pigeon pea, which is also called as arhar and tuar dal, from 72 countries. And sorghum, which is a staple both in Asia and Africa. Nearly 43,000 accessions have been collected from nearly 100 countries. And pearl millet, it's called bajra in the subcontinent. This is also collected from over 51 countries and a very staple food for many of the African countries. Over 25,000 accessions are there. And apart from this, very recently, just prior to the International Year of Millets, 2023, we also added to our gene bank more than nearly 12,000 accessions of different small millets. I'll just list those small millets going forward in this presentation. And you can also see what is the advantage of having these number of accessions in our gene bank. So with these, we have nearly 250 cultivars of groundnut were released, and they are under utilization under cultivation in 39 countries. Similarly, under cultivation in 28 countries. And pigeon pea, 124 cultivars and in 20 countries. And sorghum is probably the chart buster here, which is cultivated in 46 countries, and nearly 360 cultivars are being used by the farmers. So let me just go back to this chickpea. In fact, one of the pioneering works in chickpea ICRISAT has done is that chickpea basically is a winter crop, and normally cooler the winter, higher would be the productivity. The traditional varieties mostly loved the cool climate. But ICRISAT identified some lines which were heat tolerant. Rather, they were able to yield well even when the winter temperatures went above certain level of degrees. So that means this helped the chickpea to cross over the Vindhya mountains and come to the south of the Indian continent, and also go to many places in Myanmar and other countries where the desi type of chickpea, which is very famous for the sweet meat industry, which we call as besan. So that is the most important ingredient of the savories and the sweets. And this has a lot of demand in this country. In fact, India is not self-sufficient in chickpea. It keeps importing chickpea from countries like Canada and Australia, although the natives there in those countries don't consume chickpea. They cultivate with the sole purpose of only exporting it to India. I see some hands up. Can we wait for this presentation to be over? Thank you. We will take these questions once the presentation is over. And pearl millet again, 26 countries. And small millets. Now we are working on small millets. There are not many varieties that have been developed in small millets. There are 38 cultivar selections are being promoted in about 7 countries. So let me complete this story of chickpea. Once farmers were able to cultivate chickpea in the south of India, where the not as low as they are generally in the northern part. The chickpea almost shifted from North India to South India, and the average yield levels of chickpea are much higher than the national average. So this is one success story of chickpea. So let me go to our research approach. It's always systems. We have a systems perspective, although we are basically a crop research institute, mainly with focus on breeding high-yielding varieties having resistance to different diseases and pests. Our focus has always been on the systems. And we also work on what market needs. And we provide evidence and have a multidisciplinary approach. And we are all very sensitive to the environmental sustainability as well as business sustainability. We take farmer as the most important stakeholder in our work. And we also focus on regional global partnerships across all regions wherever we work to share the knowledge that we gather. And in our work, we address these 5 important sustainable development goals of the United Nations. So overcoming poverty, which again is a very important SDG for CIRDAP as well, and overcoming hunger, championing gender equality, then addressing climate change and partnerships. These are the most important SDGs we focus on. And we have research specialties in crop genetics, pre-breeding, breeding, the conventional breeding, and seed systems. We work on genomics, systems biology, and crop informatics. And we also work on genomes at the genome level. And the government of India has recently taken out some of the restrictions on genetic engineering that were earlier in place. Like, earlier, the gene editing was not allowed. Of course, even now, the gene transfer is not allowed from one species to another species. But gene editing within a species is possible. For example, how will this be helpful in our crop breeding work? Excuse me. So this crop breeding work, we generally, scientists will identify genes that either inhibit the yield or responsible for inducing or being susceptible for some diseases. Like I'll just take an example of groundnut. In groundnut, we were able to identify genes that are susceptible for aflatoxins. So work is still going on in terms of how we can edit this gene to offer complete resistance to the aflatoxins. So like this, if we are able to identify a particular gene in a crop that is responsible for either limiting the yield or enhancing the yield, that gene can be tweaked so that we can break the yield barrier, we can bring in the resistance, we can reduce or increase the susceptibility to a particular element. In fact, there is the long-standing aspiration would be something like offering drought resistance. There are some genes that have been identified in plants of the drought period. So if we can increase this, if we can tweak this gene, if we can edit this gene, probably we will be coming out with more drought-resistant crops. So this is the application and natural resource management, which is close to my heart. And we are in a big way into the digital innovations. And I'll also share with you some of our work on digital technologies. And we work on crop diversification, crop livestock integration, as well as biofuels. Of course, our biofuels, we worked on biofuels, especially using sorghum. But because of the current market situations in terms of the price of biofuel that we get from a vegetable source and that which is available from the natural source, so that is not very advantageous, but the technology is available for exploitation at any time in future. So we have some excellent facilities. We have what is called a Center of Excellence on Climate Change Research for plant protection. We have a Center of Excellence for Genomics and Systems Biology facility. We also have remote sensing and GIS information systems here. We have a huge phenotyping facility, which phenotyping can be done in an automated fashion on a large scale. We have our plant quarantine laboratory, which is a must for any gene bank which actually distributes or receives material from different parts of the world. So we have a platform for translational research on genome edited crops. Then we have rapid gen advancement facilities. We have a state-of-the-art soil laboratory, which is FAO accredited. And we have, as I said, state-of-the-art gene bank, probably one of the largest repository of dryland crops. We have a business incubation center also, and we also have recently started a dryland academy, which helps in skill transfer. Now let me come to the the important crops that we have, mandate crops, which we call sorghum. As I said, 333 varieties have been released, used in 46 countries, and seed production of these varieties, nearly 21,000 seeds have been produced of these important varieties of sorghum and distributed in all sorghum growing countries. And the current challenges are striga, midge resistance, drought tolerance, and biofortification. And there are some hybrids that we have identified which are striga tolerant, midge resistance is there, and they also to some extent tolerate droughts. And they could be biofortified with essential nutrient, particularly for addressing the malnutrition among the kids and particularly the young adolescents. So next crop is pearl millet, and pearl millet is again, we have several varieties in this crop, and seed is also shared with a large quantity of seed is produced and shared. And we also have high iron and zinc fortified crops. We have dual purpose lines, and we also have drought resistance and striga tolerant lines. And groundnuts, again, a very important oilseed crop in all the developing countries. And we have breeze resistant, tolerant, early maturing. And another important reason, the high oleic acid, which has a specific role in the heart health of the individuals. Of late, there's a heightened awareness about oil consumption. And it's only the olive oil which is supposed to contain high content of oleic acid. And we have identified a line and then developed it as a variety and comparable yield with the comparable yield advantage. This specific market going forward. For the moment, there are no facilities to extract oil only from the high oleic acid containing varieties. They need to be available in large quantities so that the business can take advantage of this. As I said, chickpea, again here, pan genome assembled. In fact, we have sequenced chickpea genomics. Genome sequence has been completely unraveled by the scientists of ICRISAT. And we have produced several varieties, and then large quantities of seed also has been shared. And pigeon pea is a very important crop as far as India is concerned. There are not many countries which and in the south, what is called as sambar and preparation. So we from some of the guys always fluctuates, and it is this being a long duration crop, or something like 160 to 180 days it takes. So the focus is now on developing super early maturing varieties. And another problem is fusarium wilt and sterility mosaic diseases here, which limit the yields. And our scientists are working on identifying the genes and then tweaking them. Then finger millet is a new addition. There's been a lot of work on finger millet, particularly in the states of Karnataka and Odisha of late. And this is a very important crop, contains high amount of calcium and very useful to maintain the bone health. and we are working on pigeon pea as well. And small millets, there's a range of small millets. There are something called as little millet, foxtail millet, barnyard millet, proso millet, and kodo millet. And some of these millets are native to the central India and then eastern parts of India. These germplasm has been collected. Then these have been, there's a lot of awareness that needs to be created, because these have been identified as with very low glycemic index, having implications in diabetes management. So apart from that, ICRISAT also has been working on oilseeds, not so much on its breeding, but working on its agronomy and also in its cropping systems. And now going to the most important work that ICRISAT has been known for, and the work that has been very close to my heart, and that in which I was involved. So way back in 2011 and 12, we got a small project by a foundation, Coca-Cola Foundation. ICRISAT works very closely with the CSR foundations, corporate social responsibility foundations of different corporate entities. So a project was given to ICRISAT to work towards developing resilience to drought, particularly providing water security, because there was a small village of about 1,150 hectares area, a couple of villages residing there. They used to get water in tankers during summer, and all their wells had dried, despite having a locally available traditional rainwater harvesting system called Haveli system. So that was in a condition of dilapidation. So this technique is almost 400-year-old, was practiced by the Chandela dynasty, which is about 400 to 800, dates back to 400 to 800 years. And they practiced this in the rain-fed regions. So it involves harvesting the rainwater and holding that rainwater during the monsoon season, which we call here as Kharif season. And excuse me, and when we hold this water during pre-monsoon, monsoon season, all the aquifer is recharged, and this water is used later for taking a winter crop, that is a post-rainy season crop. So not only the place where the water was held, it's a large expanse of area, something like 30-40 acres of land, that also would be available for cultivation. So the water that is held during monsoon season is let out during the post-monsoon season to provide moisture for sowing the next crop. And once the water is completely drained out, the 30-40 acres on which actually the water was earlier standing for one season will now be available for taking up something like wheat or chickpea crop, winter crops. So this is how a traditional system was there. And traditionally, these were earthen embankments holding water. But over a period of time, over nearly hundreds of years, these earthen embankments completely got destroyed. And as a result, there's because of public apathy and people relying more on only groundwater bore wells by digging bore wells. So the bore wells also need some kind of a recharging mechanism, which was completely absent in the condition in which these Havelis got dilapidated. So when we entered these villages, we could see that the water scarcity was acute, but we also identified a system of this was existing here, which was dilapidated. So we used all the modern soil and water conservation technology and the civil engineering technology. We built what is called as a core wall and avoided only the earthen embankment and provided safe disposal of water. And as a result, in just about 2-3 years, we could completely change the scenario of this land. I will just take your attention to these three GIS images here at the right-hand corner bottom here. The three maps that you see, this is the watershed, which is called as Parasai Sindh watershed in central India. So when we first entered in February 2011, the red portion that you see is all dry area. And only very little part of this was under cultivation. The green part of it But after we started reviving Havelis, the cultivation area increased. You can also see this in the graphs above these. And in 2014, the rainfall was actually, less than in 2011. And if you go to the third scenario, where in 2015, you still have some bit of a red area, which means that they were not cultivated, but still the area under cultivation is much higher than what we had in 2011. That is prior to our intervention. You will also see some small triangles in blue triangles. I'm not sure if you can make them out on your screens. And these were actually the interventions, the small structures that were constructed as part of the project to hold the rainwater and allow its infiltration into the soil. So after having gained experience of reviving a structure, a traditional rainwater harvesting structure, and bringing back into life and providing much needed water to the communities. So the government of Uttar Pradesh, in which this ecology exists, approached ICRISAT and then asked us to take up this on a higher scale. Initially, we worked on 1,150 hectares. They offered 7 districts and asked us to choose a geography of at least 5,000 hectares. And on these 5,000 hectares, take up all those interventions and revive those Havelis and bring back a lot of fallow land that was already permanent fallow to back into agriculture. So this was a huge challenge. We started working in 7 districts at the rate of 5,000 hectares in each district. And we identified nearly 80 such Havelis across all these 7 districts. And we went on repairing and renovating these Havelis with the earthen embankment. With the stone core wall and covered with this earthen embankment. What you see here as earthen embankment is actually there is a core wall, a concrete core wall inside, which is actually providing almost a leak-proof approach for this water. At the same time, in order to prevent the danger of this embankment breaching, we provided some safe disposal for this water. You can see the height of this one is lesser than this height. So there is a safe passage for the water to flow down the slope, where we have some more structures which can still hold the water. It was something like a cascading chain of Haveli structures. So all this land that you could see now in green was once, before our entry into this place, was all barren. So just to have a look at some of the important statistics. I won't go through the entire table. So when we entered this area, the groundwater table was, it was as deep as 20 to 25 meters below ground level. So once our work started, it was just 5 to 8 meters below. So the drawing water became much useful. As the water comes up, pumping also becomes easy. And you can look at how the pumping time also got reduced. And the longer you use the pump, higher will be the carbon footprint. So if we also calculated what is called as carbon footprints for producing a ton of food due to using this diesel gensets and even for that matter electricity, which is obviously produced by coal, is also responsible for producing higher carbon footprints. So you can see that it was less than half. The carbon footprint got less than half of it. So the number of irrigation, the CO2 emission for irrigation of 1 hectare land was nearly halved. From 0.179 tons per hectare, it came down to 0.084 tons per hectare. So this is how this work has an implication not only on simply providing a better, bringing back the fallow land into cultivation, producing higher food and higher amount of food, increasing the productivity, and also the last one is very, very interesting. You can see that returning migrant families, about nearly 400 to 500 families from a couple of clusters of villages had migrated to the nearby cities maybe some 20-25 years ago. Just because there was no water availability for cultivating their lands, they abandoned their land and family and everything, houses. They left. They used to be looking like what is called as ghost towns. So once they learned that this kind of work has been taken up by an institute like ours, they started returning and started cultivating these lands. Very interesting thing is that the winter season is what is called as, that is when we used to see a very high dropout of them on farm to monitor the irrigation. Because there was not enough water, they will keep on, waiting for the well to recharge, and then they will irrigate. They irrigate for 5 hours, then the well will suddenly dry. And they irrigate for another 3 hours, the well will suddenly go dry. So you will wait for the next 24, 36 hours for the one scene, and then take up. The girl children dropout during winters used to be very, very high. And what we realized is that these were all the unexpected benefits that we got from this project. We could see that girl children's enrollment also improved in the school. So now, like this, again, another satellite image you can see February that remained fallow came under cultivation in February 2020. If we can look at, again, we have plotted it against those years. See, groundwater level almost came to the brim. And well recovery period, this was what I was referring to. A well recovery period is something, what I said is that if you pump out all the water from your well tonight, and it will take about 20 hours for the same amount of water to once again come into the well. Obviously, it will slowly seep in from the lower layers of the ground and come into that well. That came down to 20 hours, 10 hours, and 10 hours, which means if you pump out all your water tonight, tomorrow night, once again, you can irrigate. But whereas earlier, they waited for almost how many days? 6 days. 4 to 6 days. They waited for almost 4 to 6 days to come back and then irrigate again. So in migration into family, this is about one village I'm talking, Birda village in Lalitpur district. This is about one village. And net area activation. So this is what you are seeing. Earlier, very few people who had 2-3 wells and who were closer to some of these water bodies were able to harvest some water and then cultivate their land. So the area cultivation steadily increased during the course of the project. And net income also, this is for the entire village cluster we have calculated. And they started bringing in livestock. They entered into pisciculture and agroforestry. So what happens is, if in a dry land there is no water, if there wants to harvest water from somewhere, his mind will start working like a horse. So that is where he will start thinking. He will start looking at where he can, use of this water and cultivate land. And what did we do? As I said, we only brought in science principles, science-based principles into this our work. See, what we did was use good material and have a good survey of the land, identify the low level points, identify the threshold of the tank capacity to hold the water, avoid of the 80 such structures across 7 districts. So just to summarize this one now, how these regenerative landscapes can transform the agri-food systems and take away the poverty in this region. So we could see that nearly 3 times increase in farmers' income, particularly those that were at a very low ebb of the economy, and water table up from 2.6 meters to 4.5 meters. It came up. So it enhanced base flow by 150%. So I'll just take a minute to explain to you what is exactly base flow. If you recall your childhood, some of you might recall that even after the rainy season stops, especially I'm talking of the dryland tropics of the subcontinent, the streams would be still alive even after 3 to 4 months of the rains, cessation of the rains. So that means if the rains stop in October, you would still see some flow in the streams even around April or well into the May. And maybe end of May, June, they would go completely dry. So, but there were streams which were perennially flowing. So that was because base flow. What is meant by base flow is that when rainfall occurs, if there is sufficient time allowed for this rainwater to get down into the lower layers, it will go and enrich and starts moving laterally. And today, one of the reasons why our rivers are dying in the subcontinent is because of the poor base flow. The forests have gone, and there is nothing to prevent the water gush in the sea. Out, take, stand, walk, and then run to the sea. So we should make the water first stand, then walk, and then slowly run. So when it is allowed to run, it will gather pace and it will create damage as well. And you also have the problems of floods, the problems of drought. All this is because of the poor water management and lack of, layers on the Mother Earth's surface, which will not allow the soil to any time to get down to the lower streams. So this is about the base. Then emission intensity, as I said, emission intensity due the energy that we use for agriculture, for lifting water and all that. So it has almost halved in the less than of from 0.14 to 0.06. It could see arrested degradation. Then 100,000 hectares fallow land was brought back into cultivation when microclimate was influenced. And this work was recognized by the UNDP, and we were awarded what is called as a UNDP Mahatma Award last year. So districts, the government of Uttar Pradesh once again came back to us and said that here is about a village cluster, which is about 28,000 hectares. And this village, group of 40 situated called Teherauli, which is India. They said that this is a perennially drought-stricken village where there is acute water scarcity, and these projects. But unfortunately, it did not materialize because this group of 40 villages stands on a ridge of a watershed, which is much higher than most of the water that is flowing. You can see there's some stream here flowing, but whereas this village is situated here. This is such a much lower elevation. If you have to get this water to these villages, then probably you will have to pump be huge. So the only one source of water, which is rain, is only be equitably distributed rains that we get. Fortunately, these areas get about 700 to 1,000 millimeters of rain. It is highly erratic. So if we can create a lot of good things here, and you can look at this, when we entered, nearly 40% of the land was fallow. About 110,000 hectares was left fallow for want of water. But when we assessed the water harvesting capacity here, there were quite a few Havelis, what you are seeing here, are, the rain gauge and other things, we have kept it here. Then we have also kept automatic weather station to completely gather all the data on these areas to work out what is called as the runoff equations for this particular ecology. So with this work, nearly 4,000 wells were rejuvenated, 5,000 wells were rated. So 5,400 wells were all dug with private investment. So nearly 4,000 of them were rejuvenated. They became operational, and people started, using water, and and well recovery period also came down here. Just in the previous study, it was brought back from out of the 11,000 hectares. So, and this area accounted for nearly 5,000 metric tons of production. So this area became almost self-sufficient. So this is about the story about looking at how the traditional water harvesting structures can be rejuvenated and brought back. Shallow lands can be brought back to cultivation, conservation, irrigation. We can protect ecology and also so that apart, we also have some other areas, cutting edge technologies, like we work on digital technology. For example, we have an app called as Plantix. It has been developed in collaboration with a German entrepreneur and the local agricultural university, which offers farmers ready solution for identifying the pest, and also suggestive measures to manage the pest in terms of whether cultural operations, sprayings, or any chemical options, various options it gives. All it takes is a smartphone. If a farmer goes to an affected part of the plant, it could be a leaf or a fruit or anything, takes a picture and then uploads into this app, and just within the next 30 seconds, you will get the redressal of your query with all kinds of options that you can take. So we also work in many areas where we fortify with information. The agromet information is strengthened, and agro advisories are issued. And pest and disease management, we work on climate smart agriculture, aflatoxin management. I already talked about aflatoxins. In fact, groundnut and pearl millet are two crops which are consumed widely, and they also have this aflatoxin problem. Aflatoxins are known to cause liver damage, liver cancer, both in humans as well as in livestock. So this is a very dangerous contamination that can happen. And of course, we talked a lot about watershed management. So now I'll definitely, you would be interested to know the work that I was trying to explain. Although it took nearly an hour, about 30 minutes for me to explain the work. You would probably imagine that how could anyone partner with ICRISAT, and what areas we can join hands, and then how ICRISAT expertise could be tapped. So ICRISAT has a very positive outlook towards developing new partnership, and it has what is called as a dryland academy, where it will give all the skill-oriented training programs for nationals of different countries, people, students, including students, practitioners, farmers, policymakers, extension functionaries. They come here regularly to not only here, to our Africa locations, to get themselves trained in various new technologies. And we can also explore joint funding opportunities. And we also have expanded our global reach with our new communication platforms. So we also are open to exploring new areas of research. For example, we are working as I said, on millets, other land races of some of the pulses like black gram, green gram, and horse gram kind of pulses. We also have a close partnership with we're keen to develop close partnership with all kinds of INGOs, the World Banks and the Islamic Development Bank, then the Africa Development Bank, and all those. So there is a huge interest, in ICRISAT by many such entities. They keep inquiring with us, and then wherever feasible, we enter into partnerships, agreements, have an MOAs. We encourage MOAs rather than MOUs. So MOA actually has a memorandum of agreement, has a specific goal in which both the entities can have a specific objective to achieve, and also the funding that is available either from a third party or from the second party. So now our role in International Year of Millet, which just passed last year, the ex-Director General of ICRISAT, Dr. Jacqueline Hughes, was the Vice Chair of the Steering Committee of the International Steering Committee that was formed by FAO. And we took a lot of our time, and we planned several events both within the country and outside in Africa. We several of our brands, such as Smart Food, cater to the business world as well. So ICRISAT has a concept called as, it is something like branded called as Smart Food. So what we say is that if the food is good for you, which is nutritious as well as healthy, and if the food growing does not harm your planet, something like using too much of water or too much of energy, so for planet, then it should also be good for farmer's pocket. Farmers' it should improve. Then such a food can be called as smart food, and we generally promote the millets as smart foods. So this is in brief about ICRISAT, although there is more to tell. But I thought that I would answer some specific questions rather than making it as a monologue for the entire duration of this webinar. Thank you very much. If you permit, I will stop sharing.
Oh, yes, I think it was a very interesting brief presentation, but it opens up definitely many questions, and maybe our participants may be interested in seeking clarifications. It is open for discussion now. Either you can ask directly or you can... Yeah, please.
Hello. Hello.
Yeah.
Hello, I'm Mojde Ketabi from Iran. If you allow me to explain successful experience of rural poverty alleviation in Iran. Allow me a brief.
Yeah, please.
Hello everyone. Thank you for the good presentation of this webinar. I'm Mojde Ketabi from Kermanshah province, Iran. I'm an expert in the field of agricultural organization in rural areas and the PhD students in extension sustainable agriculture. I want to briefly explain to you a rural poverty alleviation plan in Iran.
Can I just interrupt for a moment? Thank you very much for offering to explain. But if there is a specific question, probably we will take this question because we can make good use of this time.
Yeah.
We can certainly come back to you based on the availability of time. If based on the presentation that I made now,
type in chat box. Type in chat box.
Okay.
Yeah. You can.
Yes.
You
Send
can
you in
type in chat box as well. Yeah.
Yes. Okay. Thanks.
Thank you.
Sir, may I ask a question, sir?
Please.
Yes. Sir, when you showed that slide about the Haveli system, so it's a ancient knowledge, we
Yes.
can say. So I just want to know a little bit of history. How did you pick that Chandali dynasty system, and how did you transform it is today's technology? And would we say it as a rural innovation, sir, or innovation in rural area? Because there are lots of other ancient systems we have, but we don't pick. How did you pick those things and transform it in an today's modern technology or innovation, sir? Thank you.
You're right. This is a very interesting question, like you asked. In fact, the entire South Asia, where agriculture has been practiced as an ancient profession, has whole lot of different technologies that have emerged over hundreds of years. So, like we have, in the most dry regions of the country, one of the driest regions of our country is northwestern part, Rajasthan and Gujarat. We have what are called as a Johad system is there. We have a Tanka system is there. We have, a similar kind of what I just explained system is. So these are, and down south where we don't have perennial rivers, so there is a network of tanks which harvest this rainwater. These are called as, in the local language, they're called as Kunta, Kere, and very different names. Cheru, all these names are there. So essentially, these tanks and water bodies were built by wealthy persons or the kings of those lands, traditionally in the South Asian history I'm talking about, and particularly in down south, in south of India. A wealthy businessman, a king, or a fiefdom person owning a lot of land, a zamindar, what we call as. So these people took up building water bodies as a philanthropic work historically, because that not only agriculture, it all gave life and livelihoods to hundreds of families. This was thought as a very pious activity those days. But let us imagine that during the British era and far afterwards, there was a lot of dilapidation, because when government took up maintaining some of these things, they could not do, and the community initiative got killed. In fact, in every village, there used to be a water body, and the village committee used to manage that water body. And there were certain strict laws and bylaws, customs and traditions by which the law or the bylaws were enforced. They were never written. But, for example, if there used to be something like 2 to 3 tanks, there is one tank in which only animals can be bathed. And there is another tank where it is only strictly for drinking water purpose, where nobody should take their animal or go and bathe. Humans should not go and bathe. And there is one more very interesting system in Rajasthan, where they harvest roof water. They used to have huge houses, and during the one of the major operations during the summer, end of summer, is first they go to the rooftop and clean it with extremely they will leave any amount of soil or dirt, they will clean it, and they will not allow anyone to climb to that place with their chappals on, with their footwear on. Nobody should go with their footwear to the top, and they will prevent even young children going and sleeping on the terrace. So that water is harvested and stored for the entire next year only for drinking water, because they used to have water called as tanks just below their houses, exactly the same size of the same width and length as their house. So much is the size of the tank in which the roof water is stored, and this is for drinking water. And when guests come, one of the ways the guests were treated is to use this water and give it them for their bathing. So water was such a precious thing in our culture. So when we went into this place, we saw that these were actually telling tales there. We used to see the breached bunds, breached, earthen embankments, leaking earthen embankments. So, I mean, there is a lot of folk knowledge still exists. People will tell, like there is a 70-year-old farmer who would say that, we used to cultivate under this tank about 20, 30 acres of wheat. Now, because this, earthen embankment has breached, there is no water. So people have left this place. So then we started looking at these things. We also did some literature search, and all situated in the correct place, because it was only by observation. They did not have any great instruments to take up survey. They did not have the digital elevation maps. They did not have any dumpy levels to work. They all did it by observation over the years, in which direction the water flows, where it goes and stands, how much water can be collected. So these were all done by iterations. But now, fortunately, this generation has the advantage of using tools for promoting this kind of things. So that's how we picked this one up as one of the most important interventions, and that worked.
Thank you so much, sir. Thank you.
Any other clarifications? Yeah, for the information of participants, ICRISAT is also working on promotion of agri startups, and especially drones. Dr. Dixit may be interested in sharing a few words on that.
Sure. Actually, our crop group has been working on. We have teamed up with the government of Telangana. We are also engaged in training women, particularly on drones. And we ourselves have been using drones because we have large, farms here. In fact, we are located on a farm which spans over 3,500 acres, about 1,600 hectares. So if we want to really spray in time, we use these drones. We train our women from the looking at the droplet size and so many other things when it comes to spraying the insecticides, the drifting and if we can wind direction, wind velocity, and all those things, those standardization work is
technologies from with yet it is a I feel it is a great opportunity. Any other clarifications, questions? Yeah, I think if no clarifications, anyway, this entire talk will go to CIRDAP YouTube channel, and later also you can view this. Any clarifications in future also you can share through email with Dr. Dixit or to CIRDAP. We will facilitate. So, Madam Horain, is it time to conclude?
Yes, sir. Sir, Dr. Sreenath Dixit, sir, thank you so much for joining us. Hope you will join more in future, sir, because I particularly drawn on that Haveli system because there are lots of ancient things we didn't know. We don't know yet because it's there and it will be always there. But as people gone, the knowledge has gone with them. So that's why I asked that questions to you, sir.
Yeah.
So maybe because it's a very unique thing, sir. Thank you so much. Thank you, the participants, for joining with us. You will find. Yes, sir. Yes, sir.
I also encourage a lot of many of you to go to our website and
Yes, sir.
Look at the various resources that are available there. So
Yes, sir.
I think there were some questions. Did you have a look at this?
Chat. Yes,
In the
there are
chat
no
box?
questions. No questions.
No questions. No, fine. Okay, some comments.
So, thank you, Dr. Dixit, for your valuable time, and thanks to all the participants. Of course,
There was, I think, one Dr. Lawrence. You raised your hand in the beginning. No, is there anything that you wanted to say? I remember now.
Yes, sir.
yeah,
Dr. Lawrence.
yeah.
Could you please unmute? Okay, Miss Beta, do you have any questions?
Yes, please.
Yes, you can ask directly to the speaker.
Thank you so much for your very good presentation. At the beginning, I didn't have your voice. I would like to know type of the irrigation system. Is it only rain-fed or another? And another question is the number of irrigation is increased, as I see in your slides. What about irrigation volume, please? Thank you so much.
Sorry, what did you say? Irrigation? Last you said.
The number of irrigation is increased in your slide, as I see. I want to know about irrigation volume.
Okay.
The volume of applied water.
Okay. It varies from crop to crop. As you said, ICRISAT's work is primarily in the rain-fed areas. So as long as there are systems to harvest the rainwater and reuse it, we work on all those crops which are essentially grown on irrigation. That is used, rainwater is harvested and used. Sometimes this rainwater harvested is, it seeps and then recharges the groundwater. Even that irrigation is also encouraged. The system of irrigation here is, there is a lot of emphasis of late for using drip irrigation and sprinkler irrigation, the micro irrigation methods. So it is, of course, very difficult for crops like, field crops like sorghum or millets to irrigate through the micro irrigations, but sprinklers can be used for that. So even when we use flood irrigation or irrigation through those channels, we try to create what are called as ridges and furrows, so that there is equal amount of spread of this water in a particular plot. So yes, what you observed is, it is not the number of irrigations that has increased. It is actually the number of hours taken for recharging the well. That was more. And then, this irrigate, it is irrigation, number of irrigation wells have increased. So what earlier, because the wells had dried, became defunct because there was no recharging mechanism. So now, because of our rainwater harvesting work, more number of wells can be used for irrigating. So that is the issue. So that means, see, water is such an important element. If you don't do any other thing, just provide irrigation at the critical time, the yield will go up anyway between 15 to 25% with just irrigation at the critical time. So if we are able to provide what is called as protective irrigation or life-saving irrigation, which generally comes from the harvested rainwater, we encourage that, because there is a lot of effort involved in harvesting this rainwater. We don't encourage them to use it as a flood irrigation. We want them to use it as micro irrigation or sprinkler irrigation.
Thank you so much.
Thank you.
So,
Water is
and if yes, we can take one last questions.
Yeah.
Because it's already 13 minutes over our time. So, if anyone wants to ask any questions, if no, then okay. Yes, Mr. Shahab. Yeah, we will take your question as a last question. Okay.
yeah, please.
You can ask Mr. Shahab Hassan Bey. We are not. We don't hear you, sir. I think you're.
You're muted.
No. Could you unmute your audio, sir? Mr. Shahab.
Oh, he is muted now.
Now, yeah, now it is open.
Okay.
Yeah. So I think there is some technical, problem. Water is very
Share
important.
your question, sir. I'll be happy to answer you. Send you a mail or through CIRDAP.
Yes. Yes.
Yeah.
Okay. If you can't maintain, if you can't ask now, you can later send your question, and we will forward to the speaker, sir.
Okay,
I
thank
think
you all.
that-
In fact, it was a very interesting, presentation. It is very difficult to share in 30 minutes or 45 minutes.
Yes.
But thank you, Dr. Dixit. You made all sincere efforts to bring so many technologies. In short time, we had the opportunity to visit one is a very interesting story when the king distributed land to the citizens about 50, 60 years back. First, he brought the water, then he distributed the land. Today, that entire region in Thailand is prosperous just because of the water. So, water is very, very important. And of course, today is a very important day, International Soil Day, World Soil Day. Are very happy to, hear the talk by Dr. Sreenath Dixit on ICRISAT and its contribution for elevating poverty in Asia. Thank you, Dr. Dixit.
Thank you.
Thank you all.
Thank you
We
very
will
much.
keep in touch.
Thank you, sir. Thank you all for joining us. Thank you.
Thanks for this opportunity. It was really great to connect with so many people, and particularly to Dr. Chandrasekhar and Hurain, who
Thank you, sir.
coordinated very well and made this possible. Thanks a lot.
Thanks again, sir. Thank you.